S100 is a data framework not only for the development of the next generation electronic navigational charting products, but also for other digital products required by the hydrographic, maritime, and GIS communities. Since S57, the previous standard of S100, had been formally adopted in May 1992, S57 Edition 3.0 and S57 Edition 3.1 were released in 1996 and in 2000 respectively. After that, in order to avoid confusions on ECDIS, equipments operated on the sea, more editions became to be prohibited. Instead, IHO introduced the concept of supplements. And then IHO recognized the need of a major revision of S57, developed a new hydrographic standard based on ISO 19100, and completed S100 in 2010. S57 is limited in many ways. In order to overcome its limitations, a new standard designated S100 has been developed. S100 can be easily applied to commercial off-the-shelf software application of GIS. S100 can also be applied to various kinds of marine activities. In addition, S100 is more extensible and flexible, and it contains the concept of plug and play. S100 supports imagery and gridded data, high-density bathymetry, seafloor classification, 3D and time-varying data, dynamic ECDIS, supplementary layers that can be used with ENC and Marin GIS. S100 is developed based on ISO 19100 series of geospatial standards. Here are the key features of S100. The content of a data set and carrier are independent. And when users update the version of standard, updating is simple with plug and play. In addition, S100 can easily accommodate requirements of e-navigation, inland and port ENC, and nautical publications as well as ECDIS. S100 is PDF-type documents, and it consists of 12 chapters. One of the most significant aspects of S100 is the employment of registry and register. A registry is the entire information system in which a collection of registers is located. A register is a collection of tables containing identifiers assigned to items with descriptions, and it includes names, definitions, and usage codes. S100 registry largely consists of feature concept dictionary registers related to definitions of individuals, portrayal registers displaying symbols on the screen, metadata registers, data producer code register, and product specifications register. S100 is the data framework for database of various fields to make different product specifications. Product specifications for various hydrographic data can be developed based on S100, and numbers are given in the order of S10X. Creating product specifications using S100 is similar to using a recipe when you cook after buying some ingredients at a grocery store. In other words, S100 contains all the components to create product specifications. And if a product specification are produced based on S100, the hydrographic database can be produced in a consistent and standardized way using the product specification. The process of building product specifications based on S100 can be divided into phases. Phase 1 is user requirements. The goal of this phase is to analyze requirements of the users who need data or database. Phase 2 is data modeling, and Phase 3 is data classification and encoding. Phase 4 is creation of a product specification document, and Phase 5 is register work. The last phase is verification of product specification. One of the most representative product specifications of S100 is S101 Next Generation ENC Product Specification. S101 has been developing based on S100, and it will eventually replace S57 in the future. IHO is establishing an S100-S101 testbed and has planned to verify the new functionality of S100 product specifications. The testbed consists of multiple subsystems. Its development is iterative and is made up of 9 distinct phases. S100 1.0 was released in 2010. S100 testbed's implementation plan to verify S100, and several concepts of S100 has been established. This diagram shows S100-S101 development and implementation plan and international standard approval schedule. S100 can be defined as a framework to develop product specifications for specific data as mentioned earlier. IALA, WMO, IMO, and IOC, as well as IHO, intend to utilize S100. S101, that is one of the representative products of S100, has impacts on various stakeholders. Most of all, the introduction of S101 will have great impact on cartographers and hydrographic offices. Therefore, there will be a need to change the techniques to produce products, and ECDIS OEM will experience changes in type approval and downward compatibility. The expected benefits for end users of ENCs are a new loading strategy of cells, advanced PIC reports, noticed updates, new information type, better placement of text, new method of calculating and displaying bathymetric quality information, additional information on the ENC.